Okay guys, today we're going to talk about different kinds of properties. Now, we're going to start off with some super basic math here. I just want you to follow along as I do this. First of all, I have 5 plus 0. Now 5 plus 0, I take 5, adding nothing to it, so I get 5. 3 plus 0 gives me 3. Negative 2 plus 0 gives me negative 2. 0 plus 7, well, 7. 0 plus 0 gives me 0. Now, if I look at everything that I have in common with these problems, I am taking some number, and to that number, I am adding 0 every single time. And if you'll notice, when I take a number and I add 0 to it, it doesn't change. It keeps its identity. So this property that says when you take a number and you add it to 0 and you get back itself, that's the property called the additive identity. And again, that's just saying you can take any number and you can add 0 and it will maintain its identity. It will stay itself. Okay? Now the next property we're going to talk about, here I have 4 plus negative 4. Well, that equals 0. Negative 8 plus 8. Well, that also equals 0. And 12 plus negative 12. That equals 0. So here they're taking a number and they're adding it to its opposite, which is essentially canceling itself out and giving me a result of 0. So when you take a number and you add it to its opposite and get 0 as a result, that's what's called the additive inverse. So additive identity is when you add to 0, and additive inverse is when you add to its opposite and get 0 back. Okay? Now, just so we're all on the same page here, sometimes if you look in the book, they'll talk about additive identity and additive inverse, and then they'll talk about the same thing with subtraction. But if you guys remember from earlier this year, we talked about how any addition problem can be rewritten as a subtraction problem. So since addition and subtraction are essentially the same thing, it goes for both of them. So if I take 0 minus 5, I know that that's the same thing as 0 plus negative 5. Wow, if I could write 0. 0 plus negative 5, and that's going to give me negative 5. So that's still the additive identity. And the same thing goes with additive inverse. If I have 3 minus 3, that's the same thing as 3 plus negative 3, and that gives me a result of 0. So that's still additive inverse. Alright, next, I want to know if I take 5 and multiply it by some number, what do I have to multiply it by to get 5? Well, 1. 5 times 1 is 5. 3 times 1 is 3. 102 times 1 is 102. So here, I'm taking a number and I'm multiplying it by 1 every single time, and I'm getting back the exact same number. Again, I have this number that's maintaining its identity while being multiplied, and that's what we like to call the multiplicative identity. So whenever you take a number and multiply it by 1 and get itself back, that is the multiplicative identity. So notice the additive identity and the multiplicative identity are both ending up with the same number that they started with. Next, we're going to talk about these problems here. If I take 7 times 0, I'm going to get 0. Negative 2 times 0 gives me 0. And 0 times 137 gives me 0. So, again, what's the common factor here? We're multiplying everything by 0 and getting back 0. Well, this is actually a very, very simple property. It's going to be very easy to remember. We're multiplying, so it's going to be multiplicative. And we're multiplying by 0. So it's going to be the multiplicative property of 0. Take any number times 0 and you get 0 back. Here I have some basic multiplication fraction problems that we worked with earlier in the year. I just want to do a quick refresher. When you're multiplying fractions, it's numerator times numerator over denominator times denominator. So let's look at this first one. 3 over 4 times 4 over 3. 3 times 4 gives me 12. 4 times 3 gives me 12. And 12 over 12 definitely simplifies to 1. Here I have negative 1/3 times negative 3. Well, I can make that negative 3 over 1. Negative 1 times negative 3 is positive 3. 3 times 1 is 3. So 3 over 3 simplifies to 1. Okay. 2/5 times 5 halves. 2 times 5 is 10. 5 times 2 is 10. 10 over 10 is 1. Hopefully you're kind of noticing a pattern here. So if I were to take 9 over 16 times 16 over 9, I hope that you see that we're going to get 1 as the result. And the reason that this is happening is because I'm taking a fraction and multiplying it by its reciprocal. So whenever you take a fraction and multiply it by its reciprocal, you're always going to get 1 as the result. And that property is called the multiplicative inverse. Take a fraction, multiply it by its reciprocal, you get 1, multiplicative inverse. So those are the properties that we are going to be starting off with. We have one more here, the substitution property. Now, this says evaluate the expression 2a minus b plus 4c if a equals 1, b equals 4, and c equals 3. So with problems like these, you need to take the numerical value and substitute it in for your variable. So here, since I have 2 times a, I know that a equals 1. I can substitute 1 in for a and say 2 times 1. Minus b, well, I know that b equals 4, so I can substitute that in there, minus 4. And plus 4c, well, if I know that c equals 3, I can say plus 4 times 3. So whenever you know that something is equal to something else and you substitute it in, that's called the substitution property. Now I understand that on your sheet you have 2 additional properties. We're not going to talk about those quite yet. We're going to come back to those in just a minute. We're going to get some practice with these properties first. So on number 1, it tells us to justify each step. So here's what we have. We are actually given a T-chart. And this, on the left-hand side, they start with an expression, 24 times 1 minus 8 plus 5 times the quantity of 9 divided by 3 minus 3. And if you'll notice, there are 7 steps. And throughout these 7 steps, they are simplifying this expression to get a final result by using the order of operations. Our job is to justify each step where it came from with the properties that we just discussed. Now, step number 1. Step number 1 is always the easiest step because it's always the same thing. We want to know, where did this guy come from? Where did I get him? Well, I gave you the worksheet with the problem on it. So step number 1 is always, always, always going to be given. Now watch how we write this. On the left-hand side of the T-chart, that's going to be where all of our work is. On the right-hand side, that's going to be where our justifications are. Now, to keep things nice and neat and organized, we need to make sure that our justifications pair nicely with the steps that they go with. So notice how on the left-hand side, these steps are numbered 1, 2, 3, 4, 5, 6, 7. On the right-hand side, it's going to be the same thing, but we also need to make sure that it's nice and lined up with what we're given. So step number 1 is at the very top. Now we're going to put step number 1 at the very top here, and we're going to write that it was given. It was given to us. That's where we got it. Now, following the order of operations, just a reminder, G, E, M, D, A, S. First we need to look at grouping symbols. So if I wanted to simplify this expression, I would need to first look inside of my parentheses. 9 divided by 3 minus 3. Now, according to the operations, we need to multiply or divide before we could add or subtract. So that means I need to handle this 9 divided by 3 first. Now, if I go from step 1 to step 2, I want to make sure that's actually what they did. So if I go from 9 divided by 3, that should give me 3. And if we look, that's exactly what they did. Now, for step 2, we need to justify that. We need to say, where did that come from? Why was I able to do that? So I need to figure out which of these properties correctly identifies 9 divided by 3. So I could do additive identity, additive inverse, multiplicative identity, multiplicative property of 0, multiplicative inverse property, or the substitution property. So, remember, the additive identity and the additive inverse both have to deal with addition or subtraction. On 9 divided by 3, I definitely did not add or subtract. So both of those options are out. Now, multiplicative identity, multiplicative property of 0, and multiplicative inverse, they have to deal with multiplication. And I forgot to go over earlier, multiplication, we're smart enough to realize that we can rewrite multiplication as division. So that's really multiplication or division. So let's see if 9 divided by 3 is any of these properties. For the multiplicative identity property, you need to be able to take a number and multiply it by 1 and get back itself. So for example, 3 times 1 equals 3. Well, I definitely did not multiply a number by 1 and get back itself, so it can't be the multiplicative identity. Our next option is the multiplicative property of 0. That means for any number, I can multiply it by 0 and get 0 as a result. So like 7 times 0 equals 0. Well, 9 divided by 3, there's no 0 involved with that, so that's not my option. Next, we have the multiplicative inverse property. That's when you take a number, like 1/2, and multiply it by its reciprocal, 2 over 1, to get back a result of 1. But we didn't do that. We took 9 divided by 3, which isn't a reciprocal of each other, and we didn't get 1. So none of the multiplicative properties work. None of the additive properties work. That leaves me with one property, the substitution property. And the substitution property was the one that said if we know that something really equals something else, we can substitute that in. Now, when we talked about it, we were dealing with variables and numbers. But variables are not the only ones that you have to worry about when dealing with substitution. For example, I know, if my pen will work, I know that 1 plus 5 really equals 6. So if I'm given 1 plus 5, I can actually replace it with 6. Well, let's look at what they did here. We know that 9 divided by 3 really does equal 3. So we took this 9 divided by 3 and we substituted in 3 in its place. So substitution property needs to be kind of like the last thing that we look at. But since we know that 9 divided by 3 is 3, we substituted that in to take care of that. So step 2 is actually the substitution property. So here's how we do this. It needs to be in line with step number 2. We need to start by calling it number 2. And you must spell it out. You don't have to write property, but you must spell out the word substitution. We are not abbreviating this at all, and here's why. If we abbreviate it as SUB, how do I know if you're talking about substitution or subtraction? Substitution needs to be spelled out. And be careful how you spell it, because there are lots of T's. S-U-B, S-T-I-T-U-T-I-O-N, substitution. Okay, so still working with the order of operations. We went from that 9 divided by 3 to 3. Next, according to the order of operations, we need to make sure that we're finished with our grouping symbol. So I still have a 3 minus 3 here in the parentheses. That's what I want to simplify next. So I would take 3 minus 3 to get 0, and if I check to get from step 2 to step 3, that's exactly what they did. So now we need to see how can we justify that. What property allows me to take 3 minus 3 and get 0? Now, this is not multiplication, it's actually subtraction. So that means it's not going to be any of these multiplicative properties. That leaves me with additive identity, additive inverse, or the substitution property. So substitution we want to leave for last. Let's see if it's additive identity. That means I take a number and add it to 0 to get itself. Well, 3 minus 3, neither of those are 0. So I did not take a number and add it to 0 to get itself, so that one's out. Next is additive inverse, and that's when we take a number and add it to its opposite to get 0. Now, if I were to take 3 minus 3, and I were to rewrite that as an addition problem, I could really write that as 3 plus negative 3. Now, if you'll notice, 3 and negative 3 are opposites of one another. So when adding them together, we should get 0, which is what they did. That means 3 minus 3 is really the additive inverse property. So to write our step here, we call it step number 3. Make sure it's in line, and you can abbreviate the word additive. You cannot abbreviate the word inverse. So we're going to call this add inverse, the additive inverse property. Now, just a reminder, if I abbreviate on my page, you can abbreviate on your page. If I do not abbreviate, you cannot abbreviate. So, additive inverse property. Next, according to the order of operations, we're at step 3. So we have taken care of the grouping symbols because there's nothing left to do inside the grouping symbols. The next thing I would look for is exponents. So 24 times 1 minus 8 plus 5 times 0, we have no exponents. So then I want to handle my multiplication and division. And remember, when working with multiplication and division, you need to go from left to right. So I need to multiply or divide in order from left to right. So as I'm reading, the first multiplication or division problem that I come across, that's what I handle first. So on number 3, 24 times 1 minus 8 plus 5 times 0. So this is the first multiplication that I see. This is what I want to handle first. So if I take 24 times 1, I should just be left with 24. And if I go to step 4, that's exactly what they did. They took 24 times 1. Now, I want to see what property allows them to do that. Why am I allowed to take 24 times 1 to get 24? Well, it's multiplication, so that eliminates my additive properties. I want to leave substitution for the very end. Now let's see what happens. And I need to ask myself, did I multiply by 1 to get itself? Did I multiply by 0 to get 0? Or did I multiply by its reciprocal to get 1? So for 24 times 1, I'm multiplying by 1, and I remained with itself. It kept its identity. So this is going to be a multiplicative property, and since it didn't change, that's going to be the multiplicative identity. So again, step 4, right in line there. We can abbreviate the word multiplicative because that's a very long word, but we must write out the word identity. Okay. Next, according to order of operations, we still need to handle multiplication or division. So 24 minus 8 times 5 plus 5 times 0. I want to handle this 5 times 0. So I multiplied a number by 0 to get 0. I'd like you to pause the video and see if you can figure out which property that is. All right, hopefully you saw that this is multiplication. So addition properties, additive properties are out. Substitution we save till the end. And here I multiplied by the number 0 to get 0 as a result. And that's the easiest one of them all. That is the multiplicative property of 0. So step 5, going to be right in line there. We're going to say that this is the multiplicative property of 0, and I definitely abbreviated because that is a long one. All right, next, to get from step 5 to step 6, we're just left with addition and subtraction, and we need to go from left to right. So first I took 24 minus 8 to get 16. Now, that's subtraction, so the multiplicative properties are out. And I need to decide if it's one of the additive properties. Did I take a number and add it to 0 to get itself? Well, 24 minus 8 did not add to 0, so that's not it. Did I take a number and add it to its opposite to get 0 in return? Well, 24 minus 8 gave me 16. It did not give me 0 in return, so that's not it. That just leaves me with the substitution property. I know that 24 minus 8 is really 16, so I just put 16 in there instead. So step 6, substitution. Remember, you must spell it out. And then finally, last, we need to take 16 plus 0 and get 16. That is addition, so multiplicative properties are out. Let's leave substitution property for last. And I want you to pause the video and determine on your own if it is additive identity or additive inverse. Hopefully you guys noticed that we took a number, added it to 0, and got itself back. So we should get the additive identity property. You can abbreviate the word additive, not the word identity. Alright, so that's what we're doing today, guys. We're really just kind of trying to follow the steps and see where each one comes from. So on number 2, notice I'm given an expression and I need to simplify it all the way down and justify each step. So step 1. Step 1 is always given to you. You are always given the expression to start with, so the justification will always be given. Now, to get from step 2, let's see what they did. They should have simplified this 4 minus 3, and if I look, they definitely did. So I need to find out what property allows me to take 4 minus 3 and get 1. So it is not multiplication because it's subtraction. So the two options that I have for addition would be identity or inverse. So identity, remember, it stays the same. So 4 minus 3, did I end up staying the same when I went from 4 minus 3 to 1? Not at all. I did not add 0, so that does not work. Additive inverse is when you take a number and add it to its opposite to get 0. So did I end up with 0 as my result? No, I did not. So it's not additive identity, it's not additive inverse. That just leaves me with substitution. Step number 3. Next, we need to keep following the order of operations. We handle the grouping symbols. There are no exponents. So now we need to handle multiplication and division from left to right. So next, 7 times 1 minus 1 plus 5 times 1/5. I want to handle this 7 times 1, and I multiply those together to get 7. So essentially what I'm doing here, guys, is I want to see where did step 3 come from? What did I have to do? What property did I follow to get from step 2 to step 3? So this is multiplication, so additive properties are out. Now let's eliminate some other easy ones. Right off the bat, I know it's not the multiplicative property of 0 because I didn't multiply by 0 to get 0. So that leaves me with identity or inverse. So remember, identity, you always end up with something that you started with. So 7 times 1, did I multiply a number and end up with itself? And I sure did. 7 times 1 equals 7. I take a number, multiply it by 1, and get itself. So step 3 is the multiplicative identity property. Continue through the order of operations. So 7 minus 1 plus 5 times 1/5. I've got some multiplication here that I need to handle. So that means the additive properties are out. Let's eliminate some easy multiplicative properties. First of all, there's no zeros involved, so that dude's out. And if you'll notice, I have a fraction here. If I see fractions when I'm working with multiplication, to me that's kind of a hint that you might be working with the multiplicative inverse. So I want to see if the two numbers that I'm multiplying together are reciprocals of one another. So 5 and 1/5, that's 5 over 1 and 1 over 5. If I multiply them together, I should end up with 1, which I definitely did. Now that property is the multiplicative inverse property. Next, I took 7 minus 1 and got 6. So it is subtraction, which means the multiplicative properties are out. Let's see if we can figure out which additive property it would be. So on the additive properties, I either have identity or inverse. Now identity, you end up with the same number that you started with. Inverse, you end up with 0. Well, 7 minus 1 equals 6, so that can't be inverse because it doesn't equal 0. And the additive identity, we're adding 0. Well, I didn't add 0, so that can't be it. So that leaves me with substitution. And then finally, to get from 6 plus 1 to 7, I'm going to go through the same thought process. I have no multiplication involved. Did I take a number and add it to 0 to get itself? No, so identity's out. Did I take a number and add it to its opposite to get 0? No, so inverse is out. That leaves me with the substitution property. Alright, on number 3, what I would like you to do is pause the video and complete this problem on your own. Alright, so when we go through this, step 1 is always given. To get from step 1 to step 2, first they multiplied 4 times 2 to get 8, which would be the substitution property. Then they took 8 minus 8 to get 0. Now that's the same thing as 8 plus negative 8, so that would be the additive inverse property. Then they took 2 times 3 to get 6, which would be the substitution property. And then finally 6 plus 0 to get 6 is the additive identity property. Now if we look at number 4 is a little bit different. Notice they only gave us step 1. So what they want us to do is not only justify each step, they also want us to complete this simplification using the order of operations on our own, which is no big deal. We are able to do that. So first of all, let's justify where step number 1 came from. Step number 1 was given to us, so we can call that justification given, if this would work. Here we go. That was given to us. Now, what I want to do is I want to follow the order of operations and see what needs to happen next. Well, first, I need to make sure I handle all grouping symbols. So, 7 times 1/7 plus 6 times the quantity of 15 divided by 3 minus 5. So notice that we have 2 sets of parentheses here. When that happens, we want to simplify the innermost set of parentheses. So if I have a set of parentheses here and a set of parentheses inside of that set of parentheses, I want to complete what's ever in here before I go out to here. So that means what I want to handle first is this 15 divided by 3. So 15 divided by 3 we know is 5, so here's what we need to do. We're going to go right below number 1, and we're going to call it step number 2. And we are going to rewrite this entire expression, but we're going to simplify that first step. So what we should get is 7 times 1/7 plus 6, but instead of 15 divided by 3, we're going to put in a 5 for that, and minus 5. Now what we need to do is we need to determine where did that come from. Why was I able to take 15 divided by 3 and give a 5 in return? Now, it's addition, it's division, so that's not going to be an addition property. So let's see. Did I take a number times 1 and get itself back? So since I did not, that is not multiplicative identity. Did I take a number times 0 and get 0 back? So it's not multiplicative property of 0. And did I take a number and multiply it by its reciprocal to get 1? I did not, so it is not multiplicative inverse property, which just leaves me with the substitution property. So again, on the right side, step number 2, substitution. Next, according to the order of operations, we still need to handle any grouping symbols that we have left, which next is that 5 minus 5. So right below that, we're going to put step number 3, and we're going to rewrite my expression, but instead of 5 minus 5, we're going to work that out. So 5 minus 5 is 0, so we should be left with 7 times 1/7 plus 6 times 0. Now let's talk about where that came from. So this is subtraction, which means multiplicative properties are definitely out. And let's see what I've got. Did I take a number and add it to 0 to get itself? I did not, so it is not additive identity. Did I take a number and add it to its opposite to get 0? Well, I took a number and subtracted itself and got 0. But remember, I can rewrite that as 5 plus negative 5, so I did. This would be the additive inverse property. Next, according to the order of operations, I handled grouping. So next I want to look to see if there's any exponents, and there are not any exponents, so that is out. Then I want to handle any multiplication or division from left to right. So if I read this from left to right, I've got 7 times 1/7 right here. Now, if you look at 7 and multiply by 1 over 7, I need to turn this into a fraction to be able to multiply them. Numerator times numerator, denominator times denominator, and I'm left with 7 over 7, which is really just 1. So we can simplify this 7 times 1/7 to 1. So step 4, 1 plus 6 times 0. Now that was multiplication, so additive properties are out. Now let's see what I am left with. Did I take a number and multiply it by 1 to get itself? I did not, so that is out. Did I take a number and multiply it by 0 to get 0? I also did not. That is out. Did I take a number and multiply it by its reciprocal to get 1? I did. So that would leave me with the multiplicative inverse property. Next, according to the order of operations, I want to take this 6 times 0, and when I take 6 times 0, I'm left with 0. So step 5 is just 1 plus 0, and that is multiplication, so the additive properties are out. And this is the easiest property because we're multiplying by 0, so that's going to be the multiplicative property of 0. And then finally, we're going to take 1 plus 0 to get 1 as my result, which was addition, so the multiplicative properties are out. And I just need to determine, did I take a number and add it to 0 to get itself? 1 plus 0 equals 1. I sure did. So that would be the additive identity property. Okay, next what we're going to talk about is we're going to talk about the 2 additional properties that we haven't addressed yet, the commutative property and the associative property. So the commutative property is very simple. It says for any numbers, a plus b equals b plus a. So let's talk about that in layman's terms. What this means is if I have 1 plus 2, I know that that equals 3. Well, that's the same thing as if I were to take 2 plus 1, because 2 plus 1 also equals 3. So the commutative property says that you can change places when dealing with addition and subtraction, multiplication and division, and still be okay. So that also means that if I were to take 2 times 4 and get 8, that's the same thing as if I were to take 4 times 2 and get 8. So 1 plus 2 is the same thing as 2 plus 1. 2 times 4 is the same thing as 4 times 2. So the commutative property means that you can change places. Now the associative property has to deal with grouping symbols. The associative property says that if I were to have 1 plus 2 plus 3, and I were to have parentheses around the 1 plus 2 and simplify that, that would give me 3 plus 3, which is 6. Now that's the same thing as if I were to have 1 plus 2 plus 3, and the grouping symbols would be around the 2 plus 3. That would give me 1 plus 5, which is also 6. So notice how they still remain the same. So the associative property says you can group different terms together and still get the same results. And that works also with multiplication. If I have 1 times 2 times 3, and I were to group these two, that's the same thing as if I were to group these two. So 1 times 2 is 2, times 3 is 6. 2 times 3 is 6, times 1 is 6. So the associative property says you can group different terms and still get the same thing. So why would this be helpful to us? Well, if you look at number 5, first of all, we know step number 1 was given, so let's go ahead and label that. If we look at number 5, to get from step 1 to step 2, they didn't actually simplify anything. They just moved some numbers around. Well, why on earth would that be helpful to us? And it's helpful to us because when we're doing mental math, some numbers are easier to add or multiply together than other numbers. For example, if I were to have to take 6 times 2 times 3 times 5 in my head, I could easily take 6 times 2 and get 12. But if I had to do 12 times 3 in my head and then take that result times 5, that could be a little bit tricky. But if I look in these numbers, I see a 2 and a 5. And I know that if I multiply 2 and 5 together, I can get the number 10. And it's very easy to multiply 10 by any number in your head. So to get from step 1 to step 2, they actually switched this 2 and 3 around so that I could multiply the 2 times the 5. Now, what that did was changed those places. So to get from step 1 to step 2, they used the commutative property. Please do not abbreviate the word commutative. You can abbreviate the word property. They used the commutative property. They changed places. Now, you're probably wondering, okay, so that makes it easier because you're multiplying numbers together, but why the associative property? Remember, according to the order of operations, when you are multiplying, you have to go in order from left to right, which means that I would have to multiply 6 times 3 to get 18, 18 times 2 to get 39, 36, and then 36 times 5. See, you can clearly see that's a little tricky to do in your head. So next what they did is they used parentheses to group these together. Now, it's okay that they do that because we're working with the same signs. All of these are the same signs. So I can group the 6 and the 3 together, and I can group the 2 and the 5 together, which would be the associative property. What this has done is this made it a lot easier to do in my head because now I know 6 times 3 is 18, and 2 times 5 is 10. And I can do those in the same step, remember, because of it was separated by a lesser symbol. So grouping was separated by multiplication, so I can do those at the same time. So to get from 6 times 3 to 18 and 2 times 5 to 10, all I did was substitute one number in for the other. So that would be the substitution property. And then I can easily take 18 times 10 in my head to get 180, and that's also the substitution property. So the commutative property and the associative property are there to make it easier for us to do mental math and not have to get out our calculator. Now, let's go to number 6. Number 1, step 1 is given, always given. And let's look at what they did to get from step 1 to step 2. Notice nothing was simplified. Nothing was simplified at all. All they did was they've changed the order of the numbers. And if you change the order, that's the commutative property. Then, to get from step 2 to step 3, they just grouped different numbers together. So when you group different numbers together, that's the associative property. Now, I understand that decimals in your head are really not the easiest thing to do, but lucky for us, they did the math for us. So to get from step 3 to step 4, we used the substitution property. And I know that right off the bat because I don't see multiplying by 1, multiplying by 0, multiplying by inverses, adding the opposite or adding 0. So it's you'll get the hang of it. You'll be able to easily identify when it's substitution and when it's not. And then finally, to get from step 4 to step 5, they also use the substitution property. Now, let's talk about number 7. Number 7 starts with 5 times 7 times 4 times 2. There are many, many ways to complete these problems. There are all of these ways that you can use are all correct. So there is not one definitive correct answer. So just be aware, on your homework, if you are completing a problem like this and do it in a different way, come check with me and I can tell you if the way that you did it is correct or not. So first of all, step 1 is given, always given. Now for me, if you wanted, you could go and use your calculator and take 5 times 7 to get 35 times 4 times 2, which is substitution, then 35 times 4, which is 140, times 2, which is substitution, and then 140 times 2 is 280, which is substitution. This could be a substitution problem all the way down. You could just work your way from left to right. However, I want to use the commutative and associative properties to make it a little bit easier on myself. So I see a 5, 7, 4, and 2. Now I know that if I take a 5 times a 2, I'm definitely going to get a 10, which makes everything so much easier to work with. So I'm going to use the commutative property first, because I can't just multiply those two together and call it good, because the order of operations still comes into play. So step 2, I'm going to rewrite this expression so the 5 and the 2 are next to each other, and the 7 and the 4 are next to each other. And again, if you change the places, that's the commutative property. Then I can, if I wanted to, I could say 5 times 2 is 10, 10 times 7 is 70, 70 times 4 is 280, and go substitution, substitution, substitution. However, I want to say, well, I know that 10 times any number is a lot easier than one at a time, so I want to group these so I can do them at the same time. So step 3, I'm going to group those 5 and 2 and group that 7 and 4, and that would be the associative property. Now that I've grouped them, I can simplify both of those at the same time. So we said 5 times 2 is 10, and we know that 7 times 4 is 28. So since I used the associative property, I can definitely go 10 times 28, which would be substitution. And then finally, I can take 10 times 28 to get 280, which is also the substitution property. What's very important about these types of problems, again guys, you can solve them many different ways. If you start with the commutative property and then just want to multiply from left to right, that's definitely okay. But what is very, very important is you cannot go from step 2 to step 4. That's not how the order of operations works. If you want to multiply these two together and these two together, you have to group them first. You cannot take 5 times 2 times 7 times 4 and then go straight to 10 times 28. You have to have that associative property in there. Now, if you wanted to go 5 times 2 times 7 times 4 and then work your way down, 5 times 2 is 10. That's the substitution property. 10 times 7 is 70. That's the substitution property. 70 times 4 is 280. That's the substitution property. So you can go in that order. Just make sure you are very careful about going from 2 to 4. You have to have the associative property in there first. Now on number 8, first step, always given. I would like you to pause the video and try number 8 on your own. It's going to be very similar to number 7 if you choose to go that route, but there are many different ways that you could choose. So what I chose to do is first I rearranged things because I knew that 7 and 13 added together to be 30. Ends in a 0 because 7 plus 3 is 10, so that helps me. And then I also knew that 12 and 8 added together would give me 20, which would be easier to work with. So that would be the commutative property. But just like number 7, I can't add these two together and these two together until I group them. So I said step number 3, I grouped 17 plus 13 and I grouped 12 plus 8 using the associative property. Then once I grouped them, I could add them together to get 30 plus 20, and that would be substitution. And again, I could add them together to get 50, and that would be substitution. So what's important is that you ended up with the answer of 50. If you skipped from step 2 to step 4 and did not have step 3, I will take off points. So that would be our lesson on properties. If you guys have any questions, please make sure you come ask me.